Hello, this topic is direction sense. What is it all about? It is all there in the name, is it not? A sense of direction is called direction sense. Oh, what is there in a direction sense? Everybody knows directions, and it is natural for one to know direction, is it not? Sun rises in the east and sets in the west, and all the other direction based inputs have taught us directions. So that is easy. But in real life, we often get lost in a crowd. We're unable to find the right direction, and it happens in a lot of other places as well. It is not isolated cases, but a lot of people have problems with directions. That is a fact. Obviously, there are exceptions, but they are not the rule. Most of the people have small problems with directions. Yes, we do, and it is evident when we drive. Those who have driven bikes, cars, etc., would readily agree that we have messed up with the destinations at least once. There are some people who are good at that though. Imagine the yesteryear seafarers and travelers who never had any gadgets and still they navigated so well. It is all through great direction sense. So, let's get on with some basic knowledge of directions and then take it up from there. What are the basic directions? We know they are north, east, west, and south. How do we remember these directions? To the north, we have Jammu and Kashmir. To the east, we have Bay of Bengal. To the west, we have Arabian Sea, and to the south, we have Kanyakumari. This is known to us from our basic classes, and this is just to recollect your thoughts. When we draw this in a paper, we draw north to the top and south to the bottom of the paper. And then we draw east to the right and then west towards the left as seen in the slide. Apart from the major directions, we also have the minor directions, namely northwest, northeast, southeast, and southwest. To the northwest, we have Afghanistan. To the northeast, we have Assam. To the southeast, we have Andaman and Nicobar Islands. And to the southwest, we have Lakshadweep Islands. In case of referring to a place, it is very important to give as accurate a reference as possible so that it is easy to locate the place. This is something we know from our life experiences. So we need to have the optimum number of references to locate a place nicely. And now we have 8 reference points. It is enough to locate places very easily. A combination of all these directions will be one good way to start in terms of understanding direction sense. Now, let us look at the references more closely and from a mathematical point of view. Imagine you are standing looking in the eastern direction. How much would you be required to turn to get to the southern direction? School mathematics would tell that it is 90 degrees. Which way? In the clockwise direction. Now we have 3 parameters. 1. The original direction. 2. The degree of rotation. And 3. The direction of rotation. In the direction of rotation, we just mentioned the geometric direction being either clockwise or counterclockwise. It can also be mentioned in the common parlance of right or left. You should turn 90 degrees to the right to reach south from the east. Therefore, in common parlance, we use the 3 things, viz. The absolute direction, the degree of rotation, and our right and left to define direction. If we can use all of these in the right way, we are deemed to have good direction sense. Now, we examine each of these references in detail. There are, as we discussed earlier, 8 absolute directions: north, east, west, south, northeast, northwest, southeast, and southwest. Now look at the rotation. What is the maximum degree of rotation? It is 360 degrees. And if we turn 360 degrees, we're back to the original position. So, the range of rotation will be from 0 to 360 degrees. The angle between any two adjacent major directions is 90 degrees. Similarly, the angle between any two adjacent minor directions is also 90 degrees. Angle between north and east is 90 degrees. Angle between northeast and northwest is 90 degrees. The angle between a major direction and its adjacent minor direction is 45 degrees. Now, the angle between any two directions that are the reference directions can be easily found out as they are cumulative of these basic direction shifts. Wherever we are standing, the easiest way to point out any direction is using our hands, and therefore the right and left sides or the sides in general are very important pointers of directions. Example, he is to my left. You are standing to my right, etc. Although direction sense is very much required in life, the most potent and tangible of applications of direction sense for students is in answering aptitude questions. Most of the tests have direction sense questions. It basically tests the presence of mind of a candidate. Therefore, you will see these kinds of questions in many of the popular aptitude tests. The questions basically are of two kinds. One, where only a particular method of referencing is used, and another where a combination of references is used. In the first case, there is relatively lesser confusion, and in the second case, there is a lot of confusion. You need to have very good direction sense to answer the combination questions. Now, let us understand how to apply the sense of direction in aptitude questions. Refer the question Q1. The person Ramu moves in various directions. The distances that he moves in each direction is given. We need to find his distance and direction of his final destination from the starting point. Let us look at this step by step. First, Ramu went north for 10 kilometers. This can be represented diagrammatically using an arrow in the upward direction. As a matter of convention, we use the upward direction to indicate north. We shall indicate the distance of 10 kilometers by the side of the arrow as shown. And from there, he traveled towards the east for 5 kilometers. East is towards the right. From there, he traveled towards west for 20 kilometers. West is towards the left. From the figure, it can be seen that he retraces some distance that he had traveled earlier. And from there, he traveled towards south for 10 kilometers. The question is, how far is he from the starting point and in which direction? Look at the figure carefully. He is towards the west from the starting point and he is 15 kilometers away. Now, let us look at a combination question. Refer question Q2. Description of Rajiv's movement searching for his lost bat is described in the question. The description tells us about the turns and distances he travels in each of the directions. Let us look at the question systematically and draw a diagram to represent Rajiv's movement. Take a close look at the figure. This is the final and hybrid diagram that encapsulates all the movements mentioned in the question. A look at this figure will indicate that it hides all the complexities of the question. The figure looks plain and simple. This is the beauty of direction sense. Once you understand how to resolve issues, everything will look plain and simple. Now, let us look at the greater analysis. Rajiv started towards the north. Here is the first sign convention. North is always to be represented towards the top. Hence the travel upwards in the figure. Now look at the representation even more carefully. There is an arrowhead in them. This represents the direction of travel. Why is it there? Look at the next sentence. He takes a left. If it confuses you about which left, yours or the traveler Rajiv's, the arrow is to remove the doubt. The left and right representation is always based on the reference object, not the test taker. Here is where the arrow helps. Now, the test taker can put herself in the shoes of the traveler and identify the left. Hence the next arrow. Again, do not forget to put the arrowhead for the next travel as well. Now comes the turn. 90 degrees counterclockwise means to the left and then travel the required distance. Put yourself at the arrowhead facing the direction of the arrowhead and it will guide you properly. Travel and draw the required distance. Then the next step. Remember that you are at the arrowhead facing the direction of the arrow. Take the right and then draw the required distance. Who's right? The subject is you standing at the tip of the arrow facing the direction of the arrow. The next step is travel east. East is fixed for everybody, is it not? Will east change depending on where you stand and what direction you face? No, it will be fixed. Hence, it is called a reference. This is something that needs to be understood clearly. At whatever point, if a mention of the reference direction is made, move towards that according to the sign convention, north at the top, and that always ensures that mistakes will be avoided. And now finally, turn right and walk 20 meters. Now look carefully at the figure. It is clear that the bat is lying 10 meters west of the center from where Rajiv started. There are a lot of things that we have taken for granted, but special care should be given so that we do not commit any silly mistakes. The topic here is simple, and so the chances of making mistakes are more. We need to have some checklists to ensure that we do not make mistakes. Here are those points to remember. We've mentioned this in our discussion, but it is better to note them as consolidated points. Point number 1. There are 8 reference directions, and when a figure is drawn, it is always better if north is drawn at the top. We can relate it that way far easier than in other methods because it is the worldwide convention. Point number 2. Whenever a figure is drawn, there are 2 things to remember. A. The direction of travel is to be represented by an arrowhead. B. The figure should be to scale. In simple terms, longer distances will have longer lengths and shorter distances will have shorter lengths. The line representing 40 kilometers will always be shorter than the line representing 100 kilometers. Point number 3. To avoid confusion between left and right, always empathize with the object of travel. At every direction change, envisage that you are standing at the tip of the arrow facing the direction of the arrowhead. Then take a call on the next instruction. Point number 4. Whenever there is a mention of the standard reference points, the 8 directions, without any further thoughts, make a move in that direction as envisaged by you in the paper. Follow the normal conventions of north at the top as much as possible. We are done with basics. Now we need to move on to the advanced versions of questions in direction sense. In addition to what we have learned so far in this presentation, there is an additional concept of distances in direction sense questions. Till now, we were only bothered about the direction with respect to a reference. We need also be bothered about the distance along with the direction. As in the previous examples, it is easy to measure distance when the body in reference is either horizontal or vertical to the reference. It will not be the case always. In practical situations, the distances are not going to be horizontal and vertical only. So there needs to be a mechanism to measure distances. How can we do it? In a normal situation, in an xy plane, the shortest distance between 2 points is the length of the straight line joining those 2 points. So, to measure the distance, draw a line and measure it. That's all. But it is highly impractical to measure a line always and accurately at that. What is the most commonly used method? It is the age-old method of Pythagoras' theorem in mathematics. It is SD square equal to VD square plus HD square. SD means shortest distance, VD means vertical distance, and HD means horizontal distance. In a graph, the vertical distance and the horizontal distance can be measured easily, whereas it is difficult to measure straight line distances at an angle. As we all know, the xy plane is defined by the x and y axis. The distance parallel to the y axis for any point in the xy plane from the x axis is called the vertical distance, and the distance parallel to the x axis from the y axis is called the horizontal distance. For any 2 points, we can find out the distance between these 2 points as vertical or horizontal distances. This is the principle used in finding out the shortest distance between 2 points. Let us look at question Q3. Anu travelled 3 kilometers to her right, and from there she took a left and travelled 4 kilometers. How far is she from the starting point? Let us first draw 3 kilometers from an imaginary point where Anu was. She turns left from there and travels 4 kilometers. Look at the figure. The vertical distance is 4 kilometers and the horizontal distance is 3 kilometers. Now, the shortest distance will be equal to the square root of 4 square plus 3 square. That is equal to square root of 25, and therefore it is 5 kilometers. This is how we calculate shortest distance, and this can be done between any 2 points in the xy plane. Now, refer question Q4. Let us look at the main points of the question once again. Joseph started from a point and drove west for 50 kilometers. Then he turned left and traveled 100 kilometers. After that, he turned left again and traveled 30 kilometers. Then he traveled east for 60 kilometers. From there, he traveled 50 kilometers after turning counterclockwise 270 degrees. Now, we need to find his distance and direction from the starting point. Let us approach this step by step. Draw 50 kilometers west. Remember, west is fixed. Also, do remember to mark the arrowhead. From the arrowhead facing it, draw 100 kilometers. The left is now towards south. Do not get confused. Here, the left is of the person facing west, so it will be towards south. Draw a left again from the arrowhead for 30 kilometers. Travel 60 kilometers east. Remember, 60 kilometers east is towards the predetermined east. East never changes irrespective of the position of the arrowhead. Looking at east, turn 270 degrees counterclockwise. Now he is heading south. Draw 50 kilometers and the figure is complete. Now look at the vertical distance. He has traveled 100 kilometers south and then 50 kilometers further south. So the vertical distance is 150 kilometers. The horizontal distance will be 30 plus 60 minus 50 equals 40 kilometers. So, the shortest distance is square root of 150 squared plus 40 squared. That is equal to square root of 22,500 plus 1600, and that is equal to square root of 24,100. So, the shortest distance is square root of 24,100, and that is equal to 155.24 kilometers. By observation, we can find that the direction is towards southeast. Do not forget the calculations. You should be familiar with squares and square roots in direction sense questions. This is a cumulative question. This will involve the use of all the concepts discussed under the direction sense theory. You have to know directions, references, angular rotations, XY planes, and calculations. Hope you could get a hang of these basic requirements. If not, go through the presentation once again. All the best.